Hello, what's up? It's Papa Bale. Welcome to the channel. Please like, subscribe, and let's check out what we're doing. Hit that notification bell. Okay, so we're doing a 9-volt input, and you see we get two different amp draws with 9 volts with the system. When we spin it counterclockwise, or no, that's clockwise. When you spin it clockwise, we get half an amp draw, and counterclockwise, we get 8.8 of an amp. And as noted here, that counterclockwise draws more amps. Okay, so clockwise is this way, so that means that the coil here will be pushing the south direction, pushing the magnet going this way will be hitting south, and this way is north. So clockwise is south, counterclockwise is north, because we have a Hallback array in the disc here, and you can see where we mark north facing up, to the right, down, and to the left. So it forms a directional pattern. Why I've done this, I don't quite know yet. I haven't gotten a good tack reading or anything yet. I just wanted to see if it would work. Now we are getting definitely different amp draws for clockwise and counterclockwise. Alright, so our first addition here, our next component is the coil. And it has approximately 250 turns of 4 different gauges, 26, 28, 30, and 32. Now we have a standard bifilar connection, but we have it twice. And now we only have one input for power, and it's going at 9 volts, 9.5 volts. So that second drive and trigger, the second drive, we got drive 1, trigger 1 connected to an M.P.N. And then we got drive 2, trigger 2 connected to an M.P.N. And then this M.P.N. is connected to this M.P.N. And that's how this one gets power. So this whole second drive is operated through the first drive. When you do collector to collector, it transfers the power almost equally and laterally. It's pretty cool. And then we have another rotor, another entirely different motor with this transistor connected to this transistor via the collector to collector. And it too runs. Now I'm going to turn it on, and we're going to see this thing work with just one power input. And I think what makes it able to work is the fact that it's a power supply with a variable amp draw. So the voltage can stay the same, but the amp draw, for each disc you're spinning here, I'm pretty sure the amp draw is going to increase. But we'll go straight off the bat here. .7, 0.8. There it is. Alright, now you see this one over here, it's bouncing around, it's ready to go. So we'll get it cracking here. Look at that, man. There's no doubt that's working. That's cool. You can tell this is a double drive over here just by listening to it rev up. 0.8 amps altogether though. So this one doesn't even take a full tenth of an amp, not even 100 amps, 100 milliamps I mean. So, and then the dump is all dumped into the same place. The ground is right there, and that's just one clip. And all these transistors are grounded to that one clip. So it's a cycle, it's a loop. I'm gonna turn it off because that's getting going pretty fast. That's a ceramic bearing in there. And those magnets are just kind of attached very loosely. That's awesome. I mean, it's a little loud. I think it's the maglev, honestly, because it doesn't have a bearing in it, so it just kind of fits around the pole. And then I got a bearing on top of the maglev so that it spins, better. Because it grinds. It like grinds a little bit when it's just laying on the disc there. So those are pretty strong N42s. Those discs are N42 magnets. I'm keeping it up. It's pretty neat. I mean, it works pretty well. Now I had ceramic bearings. I still have one, but one broke. Like it was one of the little ones. I'm kind of pissed, but it's all right. That's so cool, man. I remember I was fishing around in my closet, and I remember I had this, and I'd done this experiment. Except I did it with a reed switch. This one is straight up with a coil, trigger coil. It's pretty sweet. All right. I think I got a delivery here. I'll check that out. Be right back. Yep, it was the Christmas package for my kitties. Awesome. So I'm planning on maybe adding one more disc somewhere. I know that I'm upgrading to 10mm shafts. This one is a 1/2 inch, so it's pretty nifty. And this bearing is stuck on there forever, and that sucks. It's stuck with this rotor, which could use a lathe, honestly. But it ends up being decent balance for how fast it goes. Oh man. All right. So we got going on in here from top to bottom. All right, we go in with the power. It powers the first drive and the second drive through the first drive. So this transistor down here is connected via diode to this transistor right here. And this transistor is connected via diode, rectifier diode, to that transistor over there. And all of them are being powered by this power supply at 9.4 volts. So I think that's a win. That's awesome. And again, it's not magic. It's not hocus pocus. If you want to call it free energy, you can do that. But I mean, like, there is an amp draw increase for every disc that you add if you have a power supply. I don't know if you can do this with a battery. At least not for very long with a battery. because I mean, just one circuit is going to be 9 volts and whatever its amp draw is. The total amp draw is about 850 milliamps to run both of these at 9 volts. And I think that's super in my mind, because let's do the math on that. You know, normally one motor is running at 9 volts, half an amp. Okay? We've got 2 circuits. So we got basically 2 drives pushing one motor and 1 drive pushing another motor for 300 more milliamps, which is mathematically probably exactly what it's supposed to be. But instead of having another power supply pulling these amps individually, which in my mind, I don't know if it's costing more energy or not to have 3 power supplies running instead of 1. I don't know, honestly. I mean, it's probably going to end up drawing the same amount of power. Looks like something's going on with space. It's important right now. We got to get off this rock. I mean, it's not a bad place, but I mean, I think it should be our goal to expand beyond Earth. Don't know beyond that, beyond it being a desire to see happen in my lifetime, for sure. Living on another planet would be awesome. If there was, strong communication between the planets. If you're like out there and sure in the beginning it's going to be like, okay, where the hell did everybody go, kind of thing. But hopefully we can get our act together pretty soon. I mean, there's lots of theories out there about where we came from and who we really are. So, along those lines, I think Mars would be the next logical place to inhabit. And I mean, all we got to do is start cultivating there and having those gases seep out of contained areas where these places where they're growing, and eventually you'll have an atmosphere. And depending on the growth rate and like how much effort's being put into doing it, you could definitely create an atmosphere. If there's already an atmosphere, that's not what I'm saying. What I'm saying is you can terraform the atmosphere to be habitable just by having, say, lots of greenhouses which have one-way air transfer from inside to out. Bam. There you go. And those things would be leaking the carbon and the O2 just all day, and probably at a really slow rate if you only had one greenhouse. But you get the idea, right? And the fact that there is an atmosphere, very not dense, very loose atmosphere on Mars, the gases will be contained. They are not going to 100% escape the atmosphere. They're going to be contained, and that containment will start terraforming or changing, you know. Just use the nature. Use nature. Nature knows how to do these things. Oh, that's so cool. Anyway, we did it. We did it, man. We got multiple motors. We've done it before, but we did it with a reed switch the last time. Or this particular motor was run with the reed switch. So I'm happy to ditch the switch. And we got the trigger and the coils. Tiny little things, man. Tiny little things. Compared to like everything else on the table. I mean, look. Boom. Boom. Yeah, man. Look at this monstrosity of a coil right here. That's 11,000 turns of 32 gauge. Boing. Oh. All right. Well, thank you very much. Peace out. Have a good day. Please subscribe. Bye now.